Alright, now in algebra we're going to introduce a method that sometimes I'm not a big fan of using all the time, but there are certain situations in math where you do need to do what is called completing the square. And it's using in this situation of what is the value of c such that x squared minus 10x plus c is a perfect squared trinomial. Okay, so we're going to learn some pretty cool stuff about this, because once we learn this, we can actually do some really neat stuff with parabolas and stuff. Okay, so here are going to be the steps that we're going to be working with. Okay, alright, so the first one is, alright, now if you take a look at this, this is in the form of ax squared plus bx plus c. Okay, so what we're going to do is follow along with that pattern. Okay, alright, so we are going to take half of b and square it. Okay, so that's the important part. So half of b, so that's going to be negative 10 divided by 2 is equal to negative 5, but then we're going to square that. Okay, and that should be 25, and this will always turn out to be a positive number. Okay, now if we want to check it, we would go x squared minus 10x plus 25 and see if we could factor that. And if you notice, that's a perfect square trinomial. So this becomes x minus 5 parentheses squared. Okay, now if you notice this is really nice, because this takes all of this messiness and moves it down into something nice, neat, and compact. Okay, and this will actually help us explain when we go into radicals and everything just how exactly nice this stuff is going to be. Okay. Okay, now that actually answers this type of question. So last time when we learned about factoring to solve it, we could actually work backwards and try to figure this out. And so you could actually work backwards and go x squared plus 6x equals 216, and you would go, oh, okay. Well, you would actually minus 216 from both sides, and you would get it equal to 0, because that was the rule. You have to use the zero product rule. You have to get it equal to 0. Okay, so now that you have this factoring, there's a lot of numbers that multiply to 216, negative 216, and that add up to find the combination that adds up to 6. No, sir. I do not want to mess with that. So there's a new method, and that's completing the square. Okay, now what I'm going to do is take half of b. Okay, now I know this is not exactly the same form up here. This is actually ax squared plus bx equals c. Okay, but we're still going to take half of b and square it. So in this case, half of b, 6 divided by 2, and then we're going to square it. So this equals 3 squared, which is 9. Okay, so now what we're going to do with that 9, now here's the second step of completing the square when solving. Okay, add new number to both sides. Okay, alright, so what we're going to do is add 9 to both sides. So we're going to have x squared plus 6x plus 9 equals 216 plus 9. So the new stuff that I have added, let me change it to a different color. Let's change that to green. Change this to green. Okay, is that this stuff, the new stuff is this. Now some of you guys are going, wait. How can I add 9 to both sides? Well, we've been so conditioned in mathematics that you have to subtract or add to eliminate to solve equations. Well, to go backwards, we could pretty much pretend any number. But as long as you add the same thing to both sides, it is a totally legal move. Is it something that it's very counterintuitive to what we've learned about solving equations? Yeah, it is. But sometimes this actually helps out because it makes our job a lot easier. Okay. Now, if I factor this side, this is going to be a perfect square trinomial. Now, when you do this type of stuff, what you're doing, and this is going to be 225, what you're doing is you're creating a chance to get a perfect square trinomial, because when you get that part, you can actually square root both sides. Okay, and if you notice, I now have, let's change that back to, let's go back to blue. That's going to be x plus 3. I just have an x plus 3. I don't have any more x squared, and now I have a plus or minus 15. Okay, now that does open up another can of worms. How do I find my answer for this? So when I minus 3 from both sides, I'm going to have to think about both situations. So the first situation is going to be x equals 15 minus 3, okay, which turns out to be x equals 12. Pretty easy. Okay, but the other situation that it could be, this is an or, x equals negative 15 minus 3, which is just x equals negative 18. Okay? Alright? But that actually answers both questions that I could plug x in for and actually solve for it. Okay? Alright, now some of you guys are probably also wondering, could I just graph this and set this equal to 0? By setting it equal to 0. Yes, you can. You can definitely set it equal to 0 and still graph it. Now, you have to understand that you're going to have to zoom out a little bit to get these zeros or these solutions for your graph. But you'll understand also that this is going to get you two answers that you can definitely get this way. Okay, now you have to also remember that that graphing the solutions doesn't always get you the exact answer. It'll get you a decimal approximation. So doing the completing of the square actually gets you an exact answer every time, even though sometimes it's going to be a radical. Okay, so please feel free to graph to get a rough idea of what's going on, but if you need an exact answer, you have to complete the square. Okay, so let's actually practice with some. I believe I got some in mind. X squared plus 16x, let's do minus 18. Okay, now this one's definitely not factorable, so what I'm going to do is complete the square on both. Okay, but first, before I do that, I'm going to go 16x, and I'm going to add 18 to both sides and get this. Okay, so now I'm going to complete the square by taking half of 16. So I go 16 divided by 2, and then I square it, so I'm going to get 8 squared, which is 64. Now, when I work on this, this is going to be x squared plus 16x plus 64, so I add it to the left side, and then I add it to the right side, so 18 plus 64. Okay? So remember, this number did come out of thin air, but it's because we used the method of completing the square so that we could actually just get this side to be a perfect square trinomial. So x plus 8 squared equals, I believe that would be 82. So 64 plus 18. Yep, that's 82. Alright, now what I'm going to do is, if you notice, 82 is not a perfect square root, but I can still square root it. Okay, and so what I'm going to get is x plus 8 equals, and yes, you do need the plus or minus and the square root. Now 82, we're going to leave it as is. Now sometimes the book will ask for decimal approximation. I'm going to say don't. Just leave it as is for right now. We'll talk about later what to do with that funky little beast. So what you're going to do is you're going to minus 8 both sides, and it's going to look like this. So as long as you minus 8, you should be good. Okay. Now don't minus 8 because it's on the inside. You have to remember that this right here, this is the square root of 82. We're not doing anything inside. Okay. All right. And obviously this is going to be about 9.05 is my guess, but it's going to be a plus or minus 9.05. Okay. All right. All right, guys, that's it for completing the square. You're going to have plenty of chances to practice it later on. But as long as you remember these steps, take half of b and square it, and then add the numbers to both sides, you can. Oh, that just reminds me of a trick you can actually do. Now, what you can actually do is you can actually keep them on the same side. Okay, so let's come up with x squared plus 6x equal, or let's keep this over here, minus 7. 1, 2, yeah. Okay, now what I could do is I could still complete the square with this. Okay, x squared plus 6x. Okay, I take half of 6, which is 3, and then square it, so that's 9. Okay, and then go keep the minus 7 here, but I also could minus 9 from the same side. Now the trick is in math is that you could add the same number to both sides, okay, like we did here with 64, but if you keep them on the same side, you have to both add it and subtract it at the same time. Okay, so that you understand just how that works. And then you could actually just start to manipulate it, and you could get this down to x plus 3 squared, okay, minus, was that 16? Yeah, that's 16, equals 0. Okay, so you could get it down to this form, and then you could start solving it. Okay, ooh, this actually looks out pretty sweet. So this is just x plus 3 squared equals 16. Okay, I just square root both sides. And if you notice, that is perfectly squareable. So this is x plus 3 equals plus or minus 4. Okay, and then I minus 4 from that, and x equals 4 minus 3, or negative 4 minus 3, okay, which equals 1 or negative 7. Okay, and if you notice, some of you guys are probably, some of you guys have probably already noticed that back in the beginning I could have just factored that out in the beginning. I just wanted to show you a problem where you could actually just keep them both on the same side. Okay, all right, well, that is it. And the reason why I brought it up, I'm sorry, I keep forgetting to say this. The reason why I brought it up is that sometimes you might want to add it to both sides, like over here, and sometimes you might want to keep it on the same side, like over here. Okay, there's just, it's 6 in one, half dozen in the other, what method you use for it. Okay, all right, but either way, they both work, and they're both very essential for later on in math when you're working with quadratics. Okay, all right, I'll talk to you later. Have a great day. Bye.